Hello, online biology class of summer 2011. I am Nikki Veit, and I am here to talk to you all about addiction. Now, addiction is both a fascinating topic, but it can also be a dangerous one, and sometimes results in lethal situations. Now, as we all know, addiction can come in many forms, whether it be a food addiction, a behavioral tic, sometimes even a sexual addiction. But to make things simpler, today I'm going to focus on drug addiction, specifically the hyper-addictive stimulant cocaine. Now, to quote from the ever-popular textbook, What is Life, by J. Phelan, Chapter 23 covers the nervous and motor systems of our brains, and on page 878, Phelan states, "When we behave in ways important to our evolutionary fitness, our brain releases neurotransmitters such as dopamine. Exposed to such neurotransmitter, our pleasure centers produce the sensation of bliss, and that bliss spurs us to seek out that feeling once again after it fades." Basically, this is addiction in a nutshell, an overstimulation of the dopamine receptor sites that leaves your body wanting more. First, I'm going to show you a normal animation of dopamine's regular production, but then I will show you what happens when cocaine gets mixed into the picture. When the body experiences pleasure, dopamine is released through a neuron. As this animation shows, dopamine, which is being illustrated by the little gold balls, are releasing and attaching themselves to the dopamine receptors, which enable the body to feel sensations such as bliss. However, when cocaine is introduced to the system, the drug acts as a neurotransmitter fraud, which causes the same dopamine to be released as before. However, the drug molecules bind to the reuptake sites, and the dopamine that was just released remain in the synaptic cleft. The intensity is then multiplied as the dopamine repeatedly stimulate the receptor sites, causing non-stop activity in the pleasure centers of the brain. Pretty interesting, huh? The not-so-funny thing about drug addiction is that in the early to mid-1900s, addiction was viewed as a psychological disorder rather than a physical dependence on a substance. But as technology improved and more studies were conducted, scientists were able to draw a connection between chronic cocaine use and its lasting effect on the dopamine receptors. It became clear that after an overstimulation of dopamine receptor sites, the system would result in a dopamine depletion. Once it was declared that cocaine created an overproduction and releasing of dopamine, only one other dot had to be connected to come up with a theory that cocaine addiction was a physical dependence of the brain rather than simply a psychological disorder. So what now? We have made the connection between cocaine use and dopamine receptor sites, but what good does that do us if we can't do anything to solve cocaine addiction? Well, turns out there might be a solution in the future after all. There was a new study conducted by, and forgive me if I butcher their names, Miel Huang and Chai-He Yang, in which animal studies show an ingredient in licorice called isolicoritiginin that has the ability to block the nervous system's production and releasing of dopamine. Rats were used in this scientific study in which the researchers sectioned off 4 groups of rats. One which was injected with only the isolicoritiginin, one injected only with cocaine, one with both substances, and one group of rats with nothing injected. The results showed that the rats that were injected with both the isolicoritiginin and the cocaine exemplified up to 50% less hyperlocomotion activity than the rats with only the cocaine. What seems so simple as a piece of candy that blocks dopamine production may be the next big step to finding a solution to cocaine addiction. I hope I have satisfied your cravings. If you have any further questions regarding addiction, please don't hesitate to email me. Thank you guys for watching, and have a good night.